Hello everyone, welcome back in the course of higher surveying, and we are in the lecture 2 of module 9. In the last lecture of the hydrographic survey, first of all we learned what is the importance of the tide and why should we measure the 3D coordinates of the terrain which is under the water. We said that hydrographic survey is very important for many reasons. The depth of the water, which is the height of the water above the river bed or sea bed, varies with time because of the tides, and tides are created by the combined effect of sun and moon gravitation. The height of the tide is basically decided by the moon's gravity field and the earth gravity field, and when they are in balanced state, when the gravity of the earth and the gravity force of the moon both are under equilibrium, then that equilibrium decides the height of the tide. Then we see that why the variation in the tides occur as the movement of the moon around the earth. Then we have realized what is the frequency of the tides. It could be daily, it could be fortnightly, it could be monthly, or it could be interval of 19 years. So different aspects we have learned about the recurrence of the tides. Then we looked into the terms like spring tide and neap tide. Later we have discussed very briefly that how to establish the horizontal and vertical control for the hydrographic survey. Once we collect the 3D data using sounding operations and the planimetric position methods, we will be preparing two products. One is nautical chart and another is hypsometric curve. So that is what we have discussed in our last lecture. In this lecture, we are going to talk about how to perform the survey or how to collect the 3D information of the riverbed or seabed in the given situation. The most important aspect here is, first of all, separate two surveys. One is vertical survey and other is horizontal survey, or I should say that horizontal positioning and vertical positioning are separated because we know that depth of the water or the vertical position of a point which is below the water level is to be measured by some instrument that can penetrate through the water. It could be a mechanical instrument like sounding pole or a lead line, or it could be some kind of acoustic instrument like echo sounder. On the other hand, if we talk about the horizontal positioning is obtained with the help of conventional surveying method or maybe modern methods. However, the observations are to be taken on the surface of the water. This is the location xy on which I will take the sounding. So xy location has to be known. So in this lecture, we are going to discuss mainly about the horizontal positioning methods. And these methods are decided by the given situation or the circumstances at the field site. So let us dive into the lecture. So this is our second lecture, field procedures for hydrographic surveying. So these are the books. Before we start this lecture, let us first look into the simple terms. You might have used three terms like beach, coast and shore or shoreline. So what's the difference? And is the difference important for us? In fact, yes. When we use these terms technically, especially in the context of hydrographic survey, we should be very careful. Let me first define what is beach. Many of the times we go to the beach to enjoy for the purpose of recreation. So the beach consists of the unconsolidated material. As shown in the figure here, this is kind of unconsolidated material lying over there. It could be sand, it could be rocks, it could be pebbles, it could be gravel, whatever. But it is unconsolidated, which means the voids between these particles are not filled by the water, rather filled by the air. So any part near to the sea which is like that, we should call it beach. What about the coast? Coast is like a reference line which is permanent in nature. That means it could be a firm line created by the rocks, natural rocks, or it could be a firm line created by the artificial structure. But it is permanent in nature. It cannot be changed by the movement of the water. That means water cannot cover it, or water cannot change it, water cannot displace it. And secondly, the line created by the coast is called coastline. Last term is called shore. What is the shore or shoreline? Shore is the wider fringe of the land that is geologically modified. That means if there are some small rocks, they are moved or again they are brought back by the water. and that's why the line which is created by such a phenomena is called shoreline. So shoreline is not a fixed, it's time changing phenomena, or rather at a certain time it is visible in certain position, maybe it will be changing with time. So after few days, few hours, few months, it will change. And so all the rocks which are affected by water geologically, it is a part of the shoreline. I hope you got the idea what is shore, what is coast, and what is the beach. So now let us go forward in the lecture. The horizontal control we have defined last time also, and again we are redefining it. It collects the horizontal position data. That means it will collect the xy position. It will ensure that if this is the x1 y1, it is x2 y2, this is x3 y3, they should be in coordination to each other. That means if they are in same reference frame, they should talk to each other. They should have some relationship, and that relationship should represent correct topographic information of the riverbed or seabed. It should be precise and it should be accurate. What are the general rules we should follow? The first rule is, if the width of the water body is more than 1 kilometer, in that case, what should we do? Let us say there are two shorelines and overall width of the water body is more than 1 kilometer. So what do we recommend? We should conduct this survey from both the sides. That means we should draw the lines from both the sides and we try to conduct the survey. Further, we say that use some common tie lines and connect both survey. The check lines or tie lines will ensure that the quality of the data in both are of same nature, and that's the reason the two data can talk to each other, or two data can be synthesized in one data form, and then we get the complete data set of the water body. But if the width of the water body is less than 1 kilometer, in that case we recommend that start your survey, the horizontal positioning basically from one shoreline only. One more thing here, if shoreline filled by the vegetation, then triangulation system should be adopted. At the same time, large network of triangulation system for large lake and ocean shorelines should be adopted. Now let us start with the horizontal positioning methods. So we have categorized those methods into different categories, or we have classified them. This classification is not available in the books. First is method of direct observations. That means we are observing the point xy by direct observation. It could be an angle measurement, it could be a coordinate measurement, it could be a distance measurement. That means we are not deriving it by some calculation. Rather, we are saying that let us make this position in polar coordinate system or Cartesian coordinate system, but measure it directly, and then we can later on derive some information. But our observations are very direct at the point. So first method is parallel line method, then we talk about ray method, then we talk about location by cross rope, then location by range and one angle from shore, and location by range and one angle from boat. Then we will talk about resection method, intersection method, and combination of resection and intersection method. Further, we will talk about location using intersecting ranges, then we talk about tachyometric observations, then EPS method, and finally the DGPS method, or differential global positioning method, or differential GPS method. So let us start with direct observations. So this is our first direct method where we observe the position of sounding location by direct observation. That means we are observing angle or distance, but we are observing it directly from an instrument and we are recording it. And this method is parallel line method. In the parallel line method, you can see there is a shoreline and there is some line which is appearing as a horizon. That means it could be another bank of the river or water body. We first lay down a reference line on the shoreline, and these are reference marks shown in the screen. Then this distance between the two reference mark is divided into equal intervals like this. So after dividing into the equal interval, let us mark these points here like this. On this point, we want to establish the perpendicular lines or the survey lines or our range lines. We take an optical square like this and we put on these points one by one, and using the optical square we draw survey line or the range lines which are perpendicular to the reference line. So this is first survey line which is in transverse direction to the reference line. Now we stretch float line. Let me tell you about float line. One end of the float line is tied at the reference mark, Remember, we have marked 3 reference. So one of the reference mark where I am putting this optical square. So there itself we make a peg, or we make some kind of knot here, and with the help of some nail, we take the float line shown here in the screen, which is a graduated line, and it is having bios. We stretch float line across the river. Now what happens here, this float line is having the buoys, or they are floating bodies. That's why this float line always remain on the surface of the water. Even it is visible also very clearly. These buoys are marked, or these tags are marked at a regular interval. So this float line is graduated float line. That means I know what is the distance between these 2 tags. We have stretched this float line across the river, and now we are moving from one end to another end. That means from the shoreline to the next end in the river or water body. At every location, buoys are there in a straight line. So I am measuring the distance x, or maybe the y coordinate, on the graduated float line, and if you call the range or the distance along the float line as y, then you can call the distance along the reference line as x. You move your boat along this float line, and at each and every tag point you will take the sounding observation. The sounding observation can be taken with the help of echo sounder, or lead line, or with the help of sounding pole. So all 3 methods are possible. If depth of the water body is less, we prefer sounding pole. If depth is little more than, let's say, 8 meters or 6 meters, we would prefer to have the lead line, or if depth is still more, we will take the echo sounder. The choice of the instrument depends on us for the sounding and the depth of the available water body. There are 3 types of material available: nylon, polyethylene and polypropylene. Most appropriate is polypropylene. You can see that the total weight of the 200 meter line is only 15 kg or close to 15 kg. So it is most suitable. So it is very lightweight. This is the point. So this is my distance x here, from here to here, or I can call it x1. So now I will measure y along float line. This is the situation here. At 5 meter I will take sounding, and that at 10 meter I will again take sounding observation, and so on. I repeat this process like this along the line. So I am taking the observations here, next observation at 15 meter, and next observation of sounding at 20 meter, at 25 meter, and so on. I keep on repeating this. So once I completed this line, then this boat will be turned to the next line like this. And so we will come back and we will observe these points also. That means we are observing the sounding at these points also, every point. We will repeat this process for the rest of the survey. So that is the process in the parallel line method. That means we have divided the whole area of interest or the river body into parallel lines, and we are observing the sounding readings as well as xy position at regular interval. So I am getting a very nice grid of data x, y, z. So each point is representing x, y and z. X is measured on the reference line, y is measured along the float line, and z is measured using some sounding instrument. So that is a mechanism we always follow in each and every data measurement. That means how to measure x, y. So measurement of x, y could be different techniques. However, when we measure the z, we have one sounding instrument with us. When boat comes from offshore towards the shoreline, it is called inbound run, like this. When boat goes away from the shoreline towards the offshore, we call it outbound run, like this. I hope you got the idea. So we will repeat this alternate outbound run and inbound run to cover the whole area of interest. So like this, we will collect data on these points. You can understand that we are taking the measurements x, y, z at each and every tag of the float line. We have pre-decided that what should be the distance. X1 is line spacing, and you can see here that we have done this job at very regular interval. That means line spacing is very regular and points are also placed very regularly. So I am getting a rectangular grid. Here you can imagine what are the assumptions we are making. We are making one assumption that there is no wind current. That is why it is very easy to stretch the straight float line. If river body is very small, we stretch the float line with the help of some other anchor on the other bank. First of all, since the float line is straight and it is not moving, which means there is no wind current and there is no water current. That means water body is very calm, very stable, and by this we can collect very dense data in minimum time. So this method is very efficient under circumstances where there is no wind current and there is no velocity current or the water current. So now you can see that handheld optical square used, and then the maximum allowed distance is 200 meters. That means the length of the float line is 200 meters. So if I stretch one float line, that is the maximum length we permit in case of parallel line method. What is the reason? The reason is that I want to collect some data which is very dense at very regular interval near to the shoreline and not away from that. And secondly, the assumptions of low water current and the no wind velocity is appropriate there. And that is why this method is very much restricted up to 200 meter only from the shoreline. So it is only suitable for the fishing landing areas, small fishing ports, some breakwater construction, and minor reclamation and minor excavation or small dredging purposes, and perfectly calm sea is required. Let us look into the ray method. In case of parallel line method, I assume that there is a long shoreline and we are stretching one reference line between two reference mark. Now imagine that it is not possible to establish another reference mark. That is only possible to establish one reference mark. Depending on the field situation, sometimes there is no place to establish the reference mark, or there is no way to refer the reference mark with our topographic survey. So to connect hydrographic survey with topographic survey, I need to have some control stations which are well visible to me. And let us say only one station is possible to use, and this position is this one. So what will I do now in this case? And let us say this is the area which is accessible by a surveyor. This is the kind of land area. Let us say this is the point where he will establish total station or theodolite. He will orient theodolite or total station towards this line. That means it's 0 degree, 0 minute, 0 second line, or it's 0 reference line. Now first spread a line here, and this is shoreline here. So you can see here we will stretch one survey line here like this, and let us say this angle is 8 degree. Then what we'll do, again we will observe the point like this at a regular interval, and we will measure the sounding like this, and again we will come back to the same position, back to this point. Observe few points here at regular interval. Now we have collected a couple of points along a ray line, and that is why it is called ray method. What is next? We will spread and we will stretch another ray line at a plus 5 degrees. That means increment by 5 degrees. Again we will repeat the same process like this. So we collect these points. We will come back, and then next time we will have 5 degree increment like this, and again we will collect these points. You can understand how easy the ray method is, where only one surveyor is controlling the complete survey. Any ray line can be with the help of float line, or even we can use total station or theodolite to measure these distances. But the issue is we are measuring these points at a regular interval. I need to have some device which can provide the data at regular interval, and that is why the float line is the best solution here. So spread the float line with the help of some anchor on other bank, or with the help of another boat. Another boat is stretching the float line, and at one end it is anchored at this point here, and then boats are moving. Now you are measuring the XY position with the help of float line. I can use any instrument for sounding. It is not a pseudo 3D survey. It is a perfect 3D survey where we are measuring X and Y position, and we are measuring the sounding position. So 3D data is collected always simultaneously. Although we have separated the vertical and horizontal survey here, but still we are measuring the 3 data simultaneously. In the coming slides, whenever we make the dot saying that we are taking measurement, it means we are taking all 3 measurements, X, Y and Z. So that is ray method, which is another direct method. We are observing the distance as well as the angle. So let us say at 8 degree angle, I have observed 1, 2, 3, 4 points here. I know distances of these points, so I can now make the map and mark those points. The maximum offshore distance in case of triangulation, it is 1000 meter. Here in case of ray method, that acceptable accuracies are obtained. It is preferred when the fixed points are inaccessible, and so we are using some kind of small land area. Third direct method is location by cross rope. What is this cross rope? Let us say that water body is small, 8 meter, 10 meter, 20 meter, something like that. So across this water body we can stretch graduated rope. That means it's like a float line. Although float line is needed when we want our reference line or our range line or our survey line to float over the water. So right now the requirement is not like that. Now we are stretching the rope, and this is water level here. So let's say float line is across this point and this point. Along this float line or the rope, we will take the observations like this at a regular interval, like this. So you can see here that we are measuring the XY position for each point here. At the same time, we are taking the Z by sounding. We repeat for this point, and boat will be definitely reaching here. Again, we will take another section and we will repeat this. Suppose there is a dredging, that means we want to deepen channel. So we should use this location by cross rope method. It is the most accurate method for dredging work. Width of the water body is very small. So for the small rivers and small channels, we should use this method. That means if we can stretch a straight float line, a straight rope across the two banks, then we should use this method. But it is most accurate. So for narrow lakes, small rivers, we use this method. Now again, in case of ray method, cross rope method, as well as parallel line method, we have assumed that along the any survey line, diagonal survey line, inclined survey line, or straight survey line or range line, rope is very much stable, which means there is no wind current and there is no water current. That means water is very stagnant or very still, very calm. So in that case only we use these three methods. Let us look into the direct method 4. So assume a situation where I have point B available on shoreline and we have another point A1. I plan to acquire the data along this line, which is marked here. So boat will be moving along this line and it will be collecting the data at certain points. And then we will be measuring the angle of the boat or boat as a target, and we will be measuring the angle from point B. Let us see animation. At point A1, we have a flag that is a reference mark, and again to align the line, this line, our outbound turn, we have marked A1 and A2. So A1 and A2, they are two ranging rods put there or two flags are there. So they are basically indicating one straight line. If we move along this straight line, what will happen? From the boat, one surveyor can observe that his location, ranging rod 1 and ranging rod 2, that is A2 and A1 are in straight line. So he can ensure that he is moving in a straight line. At the same time, we put a total station or theodolite at point B, and then we observe the angle of the boat at B, saying that A1B is a reference line. We are marking on this side also the same thing here. So this is outbound run, and now boat is moving, that is first point. So we have measured an angle alpha 1 here, and we have also measured the distance from A1 or maybe A2. We are not stretching any float line. How to measure the distance along this line? Once we measure distance along this line, we can mark the position of the boat because we are measuring angle alpha and distance along A1, A2 line. So then boat will go to the next position, and again from this position to this position, we are measuring the time. Let us say that we are having a clock and we are measuring the time, and using, let us say, every 5 seconds or 10 seconds or maybe every 30th second, we are measuring the sounding. So this position is sounding position, this is another sounding position, and they are at a regular time interval. That means boat is moving at a constant speed, and I am measuring the distance with the help of time measurement and the speed of the boat, that is V into T. So we are measuring distances from this point to this point. At the same time, I am measuring the angle alpha. This angle is alpha 2. We will repeat this process like this. I am noting down here x, y, z, that is the x1, y1, z1, here x2, y2, z2, and x2, y2 is calculated later by these distances. Basically, we are measuring this distance here, this distance here, and so on. And in order to measure these distances, we are using clock. That means speed of the boat into time difference. Let us see this angle is alpha 3. We should take care always that the angle which is here called beta, let us call the beta 3, here angle is beta 2, and here angle is beta 1. So, beta should always be more than 30. So, let us call beta I. So, any angle beta should be more than 30 degree to create well conditioned triangle. So, this is direct method 4, where I am observing one angle from the shore and distance from the boat. So, here I assume that the speed of the boat is fixed. That means there is no wind current, there is no water current. Again, these assumptions are valid here. So, now this is inbound run here, outbound run here. So, we repeat this process like this. In this case, if we go back in the previous slide, these are the positions which are noted down by the angle observation and not these positions here. Let us say we take every 10th reading for angle observation. So, between these 10 readings, the 9 readings are taken without the angle observation, but there we have observed the time interval and we are moving in a straight line, and that is why we know that we can always find out the angle with the help of interpolation process. The next is direct method 5. We are measuring some angle from point B. That means I am putting total station or theodolite at point B and I am observing. Understand that why can't I take the observations from the boat itself? B is reference point, A1 is also a reference point. So, there is a reference line between them. But now we are saying that we will stretch a line using A1, A2. We will move our boat like this, and then we will measure the time ticks to measure the distance from point A2 or maybe point A1. In addition to that, we will measure the angle like this. So, this alpha 1 angle. So, I move to next point now. So, in the boat again I have observed distances using the time ticks or the time interval, and again I will observe this angle alpha 2 here. We can see that we are measuring the alpha angles at certain interval, maybe 10th reading, every 10th reading we are observing. What about the intermittent reading? We are taking only the distance measurement using the time and assuming that the boat is moving with a constant speed. We can see here very clearly that once we do this kind of observation, to find out the angle values for the intermittent points, I will be using interpolation. So, similarly, this is the last point to demonstrate. This is alpha 3 angle here. So, we should again be careful that alpha I angle should always be more than 30 degree for the well conditioned triangles that are formed between A1, B and the boat. I hope that you can understand the difference of the method 4 and method 5. In case of method 4, we have one person over B and one person in the boat. That means there were 2 persons coordinating. Now, we do not have that problem. The whole survey team is in the boat and we have marked point A1 and B1 and A2. Using sextant instrument, we are measuring the angles alpha 1, alpha 2 and alpha 3 at regular interval, let us say every 10th reading. And intermittent readings are measured, or the distances are measured between the 2 points, say this point and this point. So, all these readings are measured with the help of watch. I think you can now understand better control survey, and references are used for checking. The sextant is used and the angle alpha should be more than 30 degree. Let us look into the other possibilities, the resection and intersection. What is resection? There is a point which is an unknown point that I want to establish as a control point, and here we have A, that is control point, B is another control point, and C is another control point. So, now from this point I want to find out, let us say x and y. So, I can measure these distances and these angles also. So, by these 5 measurements I can find out the position xy, and this process is called resection. That means I am determining the unknown control point by observing the known control point from the unknown control point. So, A, B, C are known control point. On the other hand, if I say point A, there is known control point, and B, there is another known control point, and this one is unknown control point. So, what if I put the total station or theodolite over here, and then I observe this distances from here and from here. Moreover, this distance is known because we know what is xa, ya, and what is xb, yb. So, this distance is, let us say, dab, and also we observe this angle alpha and beta. So, now I can fix this point and I can find out the coordinate of unknown point as xy. So, this process is called intersection. So, in intersection we have observations from A and B known control points, and in case of resection I have observations from the unknown control point. So, now we are using the same methods for the purpose of hydrographic surveys also. Point A and point B are known control points from where I am measuring the position of the boat, that is B here. So, it is boat position at a given instant. This distance d is known from the map or maybe from the field itself. Then what will I do? I will measure this angle alpha and angle beta for the current position of the boat. So, there is a person in the boat who will raise the flag, and on the flag we will take the observations from position A and position B, or control point A and control point B. So, we have measured angle alpha and beta. If we know the distance d, I can find out the coordinate of point P, x and y by these formulas. You can see here that how accurate this method is, because we have the very high control at point A and point B, because we are using some instrument like theodolite or total station, and we are measuring the angle which are not affected by any vibration of the boat or which are completely independent. Moreover, we also measure the angle theta here at the boat, and remember that theta is measured to ensure ABP is well conditioned triangle. Later on, if we find that theta is less than 30 degree, we will reject that particular observation. So, here we can see that instruments are used in place of references on ground surface, and even if there is strong current, in that case what will happen? Boat will maintain for few seconds or few minutes in certain position. During that time, surveyor who is in the boat, he will raise the flag, and using that flag position we will be measuring the angle alpha and beta. Instrument at point A and B will be targeting that reference flag which is raised by the surveyor who is in the boat. So, it is very laborious and expensive, but at the same time it is very accurate also. So, when the demand of accuracy is very high, or the wind currents are very high, or the water currents are very high, in that case we should use this intersection method. Now, look into the resection method. In case of resection, we are at point P in the boat, and from point P, one surveyor team observing angle alpha and beta to the permanent marks C and A. What does it mean? I know the coordinate of A and C in the map, and they are on the shoreline, they are permanent in nature. So, I am making this point B as reference point, and around that point B I am measuring two angles alpha and beta by sighting A and C from the boat. So, I am using the sextant here. So, this method is resection method. As we know the distance between A and B and C, I can find out the position of P at a given instant, and so this method is intelligent, at the same time it is accurate also. Moreover, these are only the permanent reference marks. So, the complete survey team is in the boat. So, small team of surveyors will also be good. So, this method is little more independent than intersection method, or it is less laborious. So, chances of mistakes are minimal here. Secondly, we should be careful enough here that the angle alpha plus beta should be more than 30 degree for the well conditioned triangle. Here, when even the points are isolated, that means these points, this point, this point, this point are to be observed. So, let us say it is P1. So, we have P2, P3, P4, and I need to perform some observations on all these points. Let us make the combination of resection method and intersection method. In this case, there is a point P where the boat is located. Point P is reference mark. At point A, we are establishing or we are setting up our instrument, say total station or theodolite, and then we measure the angle at A to the boat for the current position of the boat, and we also know the distance d. Using distance d and the angle alpha and angle beta, we can determine the position of boat P, that is xy location. Again, this method is equally good like resection and intersection method, and it is combination of resection and intersection. By using the same formula, you can find out x and y, what we have used in the intersection. Now, locations by intersecting ranges. What does it mean here? Along the shoreline, if you put a point like this, we will put a flag on first point here, and then we will put another flag here, and then we will move our boat in certain direction. So, I know what is this angle. Let us say I have observed this point here. How to observe this point? There is a flag here. As soon as the boat, which is moving along this direction, comes in this direction, it will stop and observe the x and y position here. Now, you got the idea. Since this angle is fixed here, so I can always find out what is position x and y. So, I will repeat this process. Let us say this is a flag and boat is moving parallel to the previous line. So, we determine these 2 points also. This is the next flag and we move parallel to this and we determine these points. We are getting the points at a regular interval or in a regular grid fashion. Keep on doing this, and so on. So, this method is called locations by intersecting ranges. Observations are taken periodically at a point or an area. This method is creating a regular grid, and I want to check is there any silting or scouring. For that purpose, I need to check the whole area in a very regular grid fashion or in a regular format, and for that purpose this method is useful. Basically, for the reservoirs and harbors which are very near to the port, where we expect there should not be any scouring, we generally follow this method to ensure that if is there any scouring or silting that is going to affect the available draft of water at a certain point of time. Let us look into the tachyometric observations and how do we use the tachyometric observation to find out the position. And remember one thing, when we observe the position xy on a water surface, we will always observe the depth. So, sometimes even if we say that let us take some observation, so it means that we are taking the sounding also. So, let us look into the tachyometric observations. You might have used tachyometer for basic surveying. Distance d is given by ks plus c, where s is staff intercept. We are going to use the same logic here. So, let us see, this is tachyometer put on point B here, and this is a boat having an staff as shown in the figure. This is staff intercept here s. So, this is sounding observation. This is the distance d. This is location of the point. This is the formula. D is equal to k s plus c, where this is s, this is k here and c here. For the calibrated instrument, we know that k equal to 100 and c is equal to 0. C and k values are decided after the calibration. So, in general, these are the values we take. So, I can find out the distance. What will we do next? Move the boat like this, and in this position again I will measure the staff intercept, which is increased now. I can find out the next distance, let us say d distance for this position, and at this position also we will observe the sounding measurement like this. So, this is the distance d here, which I will calculate by this formula. In this case, we can perform the sounding by using tachyometer and sounding instrument. So, now we are preparing some kind of section data here. This method is called tachyometric observation method. This is not suitable when soundings are to be taken far the offshore. It is usable only when we want our survey to be performed very near to the shore or near to the point which is very close to the shoreline. The next method is electronic positioning system. What is electronic positioning system? So far we have talked about positioning like global positioning system, but what is electronic positioning system? Well, before the GPS, there were many systems in place which are based on radio detection or microwave detection. So, electronic positioning system is basically microwave ranging system which uses the logic of triangulation. It replaces the triangulation method by distance measurement or what we call the trilateration. So, this method is now superseded by global positioning system or GPS. Now, we are using the differential GPS. Because of the differential GPS, I will come to know the exact position x and y of vessel or the boat. There is a GPS mounted in the boat and that is rover, and there is a base station we have established on the shoreline. Generally, we take a permanent station so that if we repeat the survey, we can come to know what are the changes that happen over the time in some of the positions in the sea. Let us say that there is some kind of hazard like tsunami or there was some kind of earthquake. So, what are the changes that happened in the seabed? In that case, if I use a permanent station, that will be more useful for us. Moreover, if I want to do change detection, that means over the period of time, maybe a point it is subjected to a lot of currents within the sea, and so it is being silted again and again for some reason. Take a permanent base station or a station which is permanent in nature and we establish our base on that point. What will happen? Every time I will measure vectors which are from the same base station or the same reference position, and that will give more confidence while locating some of the obstructions. DGPS method is the current state of the art technology and which has superseded all other methods. So, if DGPS is available to you, it is always advisable to use. Moreover, I would like to say one thing here, that GPS is going to measure the position only, x and y, but we need to measure the depth of the water by the sounding only. Because of the small vibrations in the boat, we need to put some kind of tilt correction with the GPS, because GPS is going to give a highly accurate XY position, but we need to have a tilt sensor. If you read the specifications of the DGPS these days, most of the DGPS which are high end, they are coming with the tilt sensor for the tilt correction, and these can be used even for the hydrographic surveys, but always consult this aspect with manufacturer of the DGPS instrument, whether this instrument is sensitive enough to use for the hydrographic survey so that we can apply the tilt correction. Be careful on this part. So far we have finished a horizontal positioning survey, that means we have located XY. Every time we are measuring the soundings, vertical depth at each and every point on the water surface wherever we have measured x and y. Now, what about the vertical control? How can we establish the vertical control? First of all, we take permanent reference mark as a benchmark which is available on the shoreline or coast. Using that, we are trying to connect our sounding instrument observations so that we can determine the sea surface or the water body surface in a certain vertical reference frame. I hope you got the idea, and that is why we call it vertical control establishment. It is very useful for the route surveys, construction surveys and topographic surveys. So, we establish the number of benchmarks depending upon the requirement of the project. It is always in conjunction with the horizontal survey. We do not separate the horizontal and vertical survey. As we have already seen how to use the lead sounding line, and we also use the echo sounders for the depth measurement, and then we also use the advanced engineering echo sounder, that means automated system. Echo sounders these days are completely automated, or we need the minimum human intervention for the echo sounders. But at the same time, we can also use lead line or we can also use the sounding pole. Well, sounding pole has a limitation of 5 to 8 meter length, so that is why it is somehow preferred only for small depths of level of 5 meter or maybe 6 meter. But the moment we go for higher depths, we should go for lead line, or if we can afford, we should go for the echo sounder. So, that is vertical control for the hydrographic survey. Here we assume that we have observed x, y and z positions. With this observation, what can we do? We can have some applications. First is, we want to find out the capacity of the reservoirs and lakes, and that is the most important application. There are two methods, one is contour method and another is cross section method. In case of contour method, again we have two methods, end area method and prismoidal method. So let us look into these two methods. So contour method gives reliable results. So that is end area method. We take some map here and now we draw a section here which is required to measure the flow or maybe velocity of the water. We develop a section by projecting these lines and we got this section here as shown here by this line. This complete section is there. We will divide this whole section into equal interval of the contours, let us say h, h and so on. Let us say on the map we measure this A1 area using planimeter. Similarly, I measure A2 area at this level and so on. Or we measure A1, A2, A3 from our hydrographic survey. That means we have derived this section from the hydrographic survey. Now we have divided this section into different levels and at each level I am determining the area which is planimetric area A1, A2 and so on. By using the simple mathematics, I can write the volume between section 1 and 2, average of the area into height is volume of the water. Similarly, I can write for each section, for this section like this and so on. I will repeat this process and finally I will add all the values here and so we got this formula. And now if you make it total here, this formula will come and there we write that first area and nth area plus 2 times all the middle areas into 0.5 times h. H is contour interval or the vertical interval, that is end area method. Let us come to the contour method where we are going to discuss the prismoidal method. Here you can see the formula L by 6, A first area, A end area and the middle area 4 times. So this standard formula for the prismoidal method where L distance between the two sections A1 and A2 and so on. So now the distance is h. So we are dividing h into two parts, h by 2 and h by 2. And now we are saying that L is equal to 2h. What does it mean? It means that I am considering 3 sections at a time, first section, middle section and the end section. The distance between the first and the middle section is h and the distance between middle and the end section is also h, and that is why the length between the first and the third section or first and the end section is 2h. So L is 2h here. So now I use this formula and I put L equal to 2h. Let us say there are 3 areas, for example A1 here, then A2, A3. So I put A1 plus 4A2 plus A3 by this formula here and then 2h by 6. Similarly, when I consider 3, 4 and 5 section, that means this one and this one. So this is h is also h here. So basically this is the h interval or what we call is contour interval. So again I am using this 2h by 6 here and then A3 plus 4 A4 and A5. So here A4 is middle area. We have covered all the areas from A1 to A5 in 2 calculations. So the total volume is given by V13 plus V35 and so if we do the summation, I will get finally this formula. Now imagine that instead of 5 areas we have total n areas A1, A2, A3 and up to An. So what we will do? We will take the contour interval h and then these areas are separated by the contour interval. Now I will take A1, that is first area, the An is the last area, and in between area I will divide into the odd areas and even areas. So A2, A4, A6 they are even areas, A3, A5, A7 and so on they are odd areas. Then I will use this formula straight away. So that is prismoidal method. So the cross section method has the moderate degree of precision and contour method is very much reliable. We can see here that traverse is run and desired topography of the shore are obtained using a stadia, that means tachymetry. Area enclosed obtained by planimeter, that means on a map I will draw the sections. Volume between the bottom part and the deepest part is neglected here. So we have the partial volumes here. So we make the summation of the partial volumes and that is total volume. But this method is much accurate. Next method is cross section method. In cross section method, moderate degree of precision is obtained. Area is basically divided into approximate triangles and trapezoids. The boundaries are sections where the soundings are obtained. So I have calculated sounding positions, and so I have prepared the sections here. So instead of reading slides, I am going to explain you what is method. In cross section method, again we have the prismoidal method. This arrangement of sections are same. So let us see, this is H1 section which I measured in the field. This is H2 section, which is nothing but a distance between A2 and A3 here, and this is AM here. AM means the middle area that I determined between A2 and A3 by some intersection scheme. Intersection could be average or intersection could be some different value. That means it depends on your interpolation scheme. So with respect to middle area, I have first area as well as end area. That means the cross section area of the two sections which are adjacent to the middle area I have observed. So basically I observe A1, A2 and so on. Then we calculate the middle cross section areas by interpolation scheme. So let us say we have complete data with us. I want to use the prismoidal method. So let us say L by 6, where L was equal to 2 times H. H1 itself is equal to 2H, because I am using A1, then I am using A2, and then I am estimating the middle area between these two sections, A1 and A2. That is why H1 is divided into two parts, H1 by 2 and H1 by 2. So basically H1 is equal to L. So now we estimate the middle area between A1 and A2 and we put it here. Similarly for A2 and A3, we put it here. And this AM is the middle area or the intersection area obtained by the intersection of A2 and A3. And similarly I repeat this process. Here I am putting H1, the distance between the A1 and A2. Here I am putting H2, the distance between the A2 and A3, and so on. Finally, after doing this calculation, we make the summation here in this formula. And this is prismoidal method here. Let us demonstrate the end area method. This is water body. This area A1, which is on the left hand side of the water body. This is cross section area. So this distance is H1 from some reference point, and then this is area A2. This is distance H2, and again this is area A3, and so on. Finally, I have A7 area which is at the end here like this, and similarly A1 is also there. So what are formulas now? These are formulas by end area method. That means I take the average of the two areas, let us say A1 and A2, and then I will multiply by this height H1 or this distance H1. Similarly, I will repeat the whole process, and finally I get the total volume of the water by summation. This is end area method for the cross section method. We have taken some of the images from some sources. Here we finished our lecture 2, and in the third lecture we will look into the operations of the echo sounder for the sounding measurement or the vertical depth measurement of the seabed. Thank you very much. So